Good morning for the North American team, good afternoon for the European, also good evening for anyone who's joined from the Asia and Asia Pacific. Today, my friend Norbert Bissmeyer and I will present to you the basically how to realize secure V2X PKI and integrate it with your entire ecosystem to be able to realize the V2X feature and introduce safety and reliability into your vehicle fleet. Of course, that in context for the North American, European, and China standard. And we welcome all questions as presented by Allah today. So I have my camera on at the beginning, but when I proceed with the deck, I'll try to turn it off to maintain bandwidth and no challenges during the presentation. Okay, so we'll start here at the beginning. So this is the today's agenda in high level. Who's ETAS? We'll also talk about the global market launch for V2X, give some trends and some numbers. The challenges that we try to address today, basically, what are the pain points that we've learned throughout the engagement with our leads and customers for the last few years, I would say, and also the proposed solution by ETAS to be able to address the challenges that we will talk about today. And then, last but not least, why you would need to work with ETAS and what is the proposed solution that helps you alleviate your pain point, try to realize a cost-efficient PKI system. And then we conclude the deck for today. So ETAS, before I go on ETAS, try to give some short and brief bio about the presenters. So my name is Omar Alshabibi. I'm the lead product manager for automotive cybersecurity solutions at ETAS. I'm basically responsible for different product within the security portfolio. It starts from the embedded systems within the vehicle into the cloud and backend security systems. I like to fix customers' problems, delight our customers, and create value to our target market and to our organization. I'm located in Waterloo, Ontario, Canada, and basically we are, let's say, in the west of Toronto and about 3.5 hours from Michigan. Norbert, hand it to you to introduce yourself. You're muted, Norbert.
Hi, my name is Norbert Bissmeyer. I'm a security expert and the product owner for our product development for the V2X PKI. I'm a security expert in this field for more than 12 years, working towards standardization of this technology, doing security analysis, security concepts, and also following the standardization and auditing of the systems around. I'm located in Bochum, Germany, and I'm happy to present here our technical solution.
Thank you, Norbert. So let's deep dive here. Welcome to ETAS. Who's ETAS? ETAS, founded in 1994, it's a whole subsidiary of Bosch GmbH, and it's co-founded out of Bosch, basically, and presented 12 countries in Europe, North America, and Asia, South America, as well as Asia. ETAS basically serves the automotive market and help the customers to develop and operate with increased efficiency, Tier 1 and OEMs, with wide range of portfolio presents by vehicles, basic software, middleware, development tool, and all the products and services that ETAS develops and put out to the market towards realizing the vision and strategy of software-defined vehicle. This is what we're trying to rally around this mission and help our customers achieve their vision as well. Escrypt is the security brand of ETAS, and basically Norbert and I are part of Escrypt division within ETAS, what we call the solution field security, specialized in cybersecurity for automotive industry, from connecting the vehicle into the back-end cloud solution for the automotive industry, as well as consulting or professional services. This is what we call the holistic cybersecurity solution within ETAS. Of course, both companies are owned by Bosch GmbH 100%. So ETAS in numbers here, 494, as I said, we have 31 locations globally in 12 countries. It's about 1,500 associates, revenue around 330 million euro, and the associated brand for today's conversation is Escort, as I mentioned earlier. Now, I would like basically to just touch briefly on what is the V2X here, to socialize this information just in case we have a new members of the V2X community here, and to help communicate the message in more clear and easy way. So V2X is a secure communication between vehicle and the surrounding environment, such as other vehicle or infrastructure. That's what we call V2X. It presents V2V, V2I, and eventually V2P, vehicle to pedestrian. The technology uses the communication, whether it's a ETAS G5 or DSCRC, dedicated short-range communication, or the cellular V2X technology. The main or primary function of the V2X is to bring safety, increase reliability of the communication, and reliability of the connected autonomous vehicle by having this additional sensor, like the V2X sensor, in the vehicles to realize the reduced collision and help, having the interactive capabilities between the vehicle and the surrounding environment. Imagine, like, all the sensors that you have now in the vehicles, like radar, LiDAR, cameras, they're all great sensors. They all try to accomplish what it's intended to do. But there are certain conditions and circumstances that allow all these sensors to operate efficiently and effectively. While the V2X is basically your broadcast messages, and we talk about 300, 400 meters away, that you could receive a message and be able to take actions ahead of time to prevent collisions or prevent problems from happening. So meaning it's like, it's another perception that is added to the vehicle capability in terms of realizing safety, and also help the driver to make informed decisions on time. With the entire V2X ecosystem, it's designed from the beginning with strict requirement for both security and privacy, and that is important because you don't want to track vehicles and connect it to drivers, but you would like to increase that adoption by having the safety feature installed in the vehicle with realization of having a secure communication. And of course, as I said, the primary function is safety, expected to reduce 80% of vehicle collision, which is a significant number, and saves lives and move forward. So these are the V2V, V2I messages. As you can see here, the V2X ecosystem basically represents of two key sensors: the V2X ECU within the vehicle and the roadside infrastructure. Roadside unit. Roadside unit is basically connected close to the traffic signal and also broadcast safety messages all about the conditions of the intersection to help the driver and vehicle take necessary actions on time. Some of the safety beacon messages, like the basic safety message here, we talk about location, speed, heading, size, and so forth. All the messages that you broadcast, you can see here in that automated picture, is all require security and privacy. And that's the key message here. And this is what we're trying to address today. Move forward. So the security for the communication technology of the V2X, as I said at the beginning, we have the two types of communication, CV2X and ETAS G5, the Wi-Fi based or the cellular CV2X. The security is agnostic for the type of communication. It's independent of the air interface because both communication methods require digital certificates. The V2X digital certificates is based on the IEEE 16009.2. It's unlike the regular standard X549 digital certificates that we use for our own regular communication, browsing, emails, and so forth, right? Both communication methods use the same message sets and safety use cases. And that's basically on the security for communication. When it comes into dedicated short-range communications, are using the wireless standard called WAVE. And the term cellular doesn't mean that you're using the backhaul of the cellular network, but you use the underlying technology in the cellular radio to communicate from one vehicle to another vehicle, from one vehicle to infrastructure and so forth. So to move forward here, why OEMs do need to basically care about the V2X feature. It comes into, to simplify it, it's all about safety and reliability. As I mentioned earlier, you have sensors in the vehicles. They are doing the job that intended to do for certain things. To increase that safety, to realize advanced level of autonomous vehicle, you need additional sensor to increase that safety and help the drivers to use the technology with ease of mind, right? When you see that vehicle is well equipped with all different sensors, well equipped with a technology that you can see non-line of sight technology, basically, that put it that way, right? Non-line of sight technology, it helps add the value to the vehicle, add the value to the driver, and eventually to the automotive OEMs. Some numbers here. V2X communication is already deployed by automotive OEMs, roadside infrastructure. There's a global data shows about 500,000 vehicles benefiting from V2X day one services based on some safety messages, and 20,000 kilometers of roads equipped with V2X roadside units in Europe alone. A communication layer from the V2X sensor can add further improvement to SAE level 5 compliance, and also considered by the European NCAP as a technology that allows vehicle to receive advanced warning for potential hazards. So this is all about safety. We also hear about the NCAP that it's going to introduce the V2X feature into their rating, so you can get the high rating or 5 stars rating based on having additional safety feature within the vehicle based on the V2X sensor. So this is, the thing here. So now what the objective of this webinar is to talk about the challenges and proposed solution for these challenges. So the challenges we try to address here, basically, it's about the end entity, which are the devices. End entity represents the roadside unit by the ETAS operator. And also for the automotive OEMs is basically the end entity, the V2X ECU. Our main topic and focus of today is addressing the automotive market specifically. So what are these challenges? What are we trying to fix here? Based on our engagement, based on our understanding to the challenges that OEMs are facing, by interviewing, listening to our customers, having a deep dive conversation, we realize that the bootstrapping and there are some facts and some realization as well. The fact is the bootstrapping and initial enrollment processes of a new end entities like vehicle is not completely standardized globally. That area left open. It gives some, ability to the automotive OEMs to design a solution that meet and fit their purpose, cost and deployment and so forth, right? But also adds challenges. Not clear if automotive OEMs can leverage existing security infrastructure for end entity bootstrapping. Bootstrapping is the entire process as explained to enroll the entire device and their lifecycle management. So from our listening to our target audience, we realize that there is, some, unclear, there's no clarity here when it comes into whether I could use my existing PKI infrastructure, or what could I do with the existing PKI infrastructure if I need to introduce a new V2X PKI into my system. Now, the last thing here we could see, of course, there are multiple items, but we try to summarize it here. This is more of like a high-level challenges. Managing different enrollment solutions is complex. Period, right? If you try, to have, different set of skill set within the team, you try to have basically an environment you have to separate, you need to pay for these services and so forth. So that alone, it adds complexity and cost. Now, what we're trying to do as a company, we try to introduce a solution that actually address these challenges and help the OEMs adopt the technology and move forward. So Before I deep dive into the proposed harmonized solution, and that will basically tended to be, I will hand it off to my friend, Norbert Bissmeyer. There's a short survey that I would like your help to basically answer, and we can take it from there. So that is, one of the things that helps to move us and put us in a position to really understand more and more, and help us shape our strategy, shape the solution, and address the market challenges. Okay, Norbert, I think
yes,
can hand it off to you now.
Okay.
Thank you, everybody. I will get back to you shortly. Thanks.
Yeah, let me continue from this point on. So the goal is to present a harmonized solution, because you might be aware that there is a standardization around the security for V2X PKI and for V2X in general, in particular in Europe, in North America, and in China. There are standards available. There is some kind of harmonization of the certificate formats and the structure, but some aspects are open in this solution, and we want to focus into these white spot areas and provide a potential solution for you. Before I go into these solutions, I want to introduce the technology a little bit. So on this slide, you can see an overview of the security architecture, and the main component you can see here in the middle of the slide is the V2X PKI. The PKI is a public key infrastructure, and this is a so-called trusted third party in the system that is providing certificates to all the end entities, which are in this picture a vehicle you can see here on the left and another vehicle on the right. And you can also see some roadside infrastructure components that also get certificates. And this is relevant that all the systems, all the components, all the end entities get a certificate from the trusted third party PKI in the middle, because with these certificates, each and every sender of V2X messages can sign or do sign their messages. And based on the message, based on the message signature that is attached to each message that is sent out, for example, on this link or on the link above from a vehicle to a roadside equipment, the receiver can verify the signature that the sender is a valid sender in the system. And since in most cases, the receiver of a message has no idea that the sender is trustworthy, because it's probably the first time that the receiver has communication contact with this sender, we need this trusted third party, because this trusted third party is used to provide the certificates, and by verifying the certificate of the sender which sent the message, this receiver can verify that first the message is valid, the message is not modified, and then that the sender of the message is authentic and is trustworthy. And this is why we need the PKI, because in this scenario, we have all the end entities, all the vehicles on the road, which have no constant backend connectivity, even no fast backend connectivity, to allow this very fast, low latency communication, because it should be fulfilled that a message can be directly verified by a receiver without establishing a backend connection to download crypto material. In this solution, the sender is signing the message and the receiver is directly verifying the message and can use the information and can process it for its functions. All this system you can see here on this slide, most of this is certified and is standardized, but what is the open point you can see here is on the left-hand side. Because we have the question in general, when we want to provide certificates as a PKI operator to a vehicle, which of the vehicles are trustworthy to get these certificates? So it's just one step before the vehicles are driving on the road and sending out messages. We as a PKI operator, we have to check which of the requesting vehicles are trusted and authentic and authorized to get the certificates. And this process is not standardized, and it's intentionally not standardized to allow different variants for these initial registration, or you can name it enrollment, into the PKI. And this includes bootstrapping of the device. Let's focus here on this vehicle, for example. So how the PKI information is going to the vehicle is not standardized, because you can imagine that the different OEMs worldwide have different manufacturing processes. And here it's intentionally left open how this bootstrapping, this feeding the data into the devices is done. And in the same way, the initial registration, so the other side of the other direction of communication, how to inform the PKI that a new vehicle in the production, on the production line, for example, is trustworthy and is allowed to get certificates. Okay, and this is then relevant for later functionality in the maintenance of the vehicles, also in repair cases. Here you can imagine that there is no standardized mechanism for all the OEMs worldwide to do it in the same way. Therefore, it's intentionally left open how these management of the vehicle itself can be done before they get certificates from the PKI. To go the next step, we filled this gap here on the left-hand side by some boxes, which are quite some obvious. So the box here in the middle, which has direct contact to the PKI, is the vehicle operator. This could be the OEM or could be another service operator for the OEM, who is taking care that the communication from a vehicle to the V2X PKI is correct and is maybe going through a firewall so that not everybody can access the interfaces. Then you can see here on the left-hand side a factory production line, which is involved in the production of the V2X communication device, or actually of the vehicle itself. And then what Omar introduced in this presentation, in this webinar, is that we want to reuse an existing X509 PKI. And such a X509 PKI can be used, or is already being used by vehicle operators to secure use cases like remote diagnosis, like remote software updates, like remote access to the vehicle so that the driver can, over the smartphone, access the vehicle. All these use cases are already secured, of course, and standard PKIs are usually applied here, which is of technical type X509. And we are looking now in this webinar how this existing infrastructure can be reused to make the life easier to introduce the new use case for V2X communication, in particular to solve the issue to enroll and bootstrap new devices at the PKI so that the standard conform request of V2X specific certificates can be started. And these standardized processes, which consist of the acquisition of authorization certificates. So these authorization certificates are the V2X specific certificates. They have a specific certificate type, different to X509, because the wireless communication on the road need to use certificates which has a minimum size. And the classical X509 certificates have a much bigger size, roughly 10 times bigger than these specialized V2X certificates. That's the reason we need this specialized V2X PKI to secure the wireless communication. But of course, we can reuse existing certificates to enable the initial communication with the PKI. And this also concerns the download of revocation information, which need to be done regularly by the vehicles, and later on sending of potential misbehavior reports from the vehicle to the V2X PKI, which is also partly standardized in some region in some standards. So this is the overview of the architecture. And on the next slide, we think about different options, how this existing X509 infrastructure, PKI infrastructure, can be reused to to keep the system simple and reduce the effort for the OEM to manage the vehicles. So the first option is that the X509 PKI that already exists is just extended by issuing additional certificates of the same type, X509, to the vehicles that should be enrolled, and therefore the vehicles get a new certificate which is considered as an enrollment certificate. So actually it's fully integrated in the potentially available infrastructure and available processes at the OEM to give certificates to vehicles, to update the certificates, to take care about revocation of vehicles. And now it's just another certificate that is issued for this new purpose for V2X communication. So in this option, this certificate is considered as an enrollment certificate. And yeah, as said, I will go in the next slide into a little bit more detail for this option. So this is just a summary. So this option is reusing the X509 PKI as much as possible to reduce additional new processes for V2X to a minimum, and therefore to reduce the effort for operations to an absolutely minimum. It needs to be considered that in this case, also the X509 PKI need to become scope of an audit and the certification of the V2X PKI, which I will explain on the next following slide a little bit in more detail. The second option we see or can propose is that we want to avoid a deep integration of the X509 PKI, of the existing PKI, to avoid the deep integration into new certification, into new audits, by having a more clear separation between the existing use cases and the new use cases for V2X. And here it's just a balance between using the existing PKI to reuse all the functions for, as I said, enrollment, maintenance, revocation, but also use them still to enable the request of V2X certificates. And then the third option could be that there is an OEM who has no X509 PKI available. This is, of course, also an option to really clearly separate the X509 PKI and other use cases from V2X use cases and the management. So this is a clear separation where this has no impact for certification for audits. But on the other hand, you have to consider additional functionalities, interfaces, processes to manage the initial enrollment and bootstrapping of vehicles. It can be a quick start to integrate a V2X PKI into the system, do some analysis, and maybe then decide, that still option 1 or option 2 could make sense if X509 PKI infrastructure is available, or simply continue without an X509 PKI. To give you a little bit more information, we created some detailed slides for these 3 options. So you probably recognize this picture. You have in the middle the vehicle operator network, the existing X509 PKI, and some kind of factory, could be a supplier, tier 1 supplier, or could be the OEM itself in the assembly of the vehicle. It depends where the V2X communication unit is integrated into the vehicle itself. And then on the right-hand side, you have the V2X PKI that is finally issuing the certificates for V2X communication. And I wanted to explain that certification and audit of the V2X PKI is relevant because here we are talking about external communication. So it's not only within the OEM, within the known and trusted vehicles. Here it's about communication to others, and potentially others need to know whether this PKI and all this infrastructure is trustworthy and is hardened against attackers. Therefore, at least in Europe, there is a certificate policy available that need to be followed if such a PKI is operated. In North America and in China, there are activities ongoing regarding a certification auditing of this solution to enable that all the stakeholders in the system can trust each other on the same level and can consume the messages in the same way, so that trust in the information is given. So that's the reason certification and auditing need to be considered, because this happens periodically, and this has also some requirements regarding crypto algorithms, protocols that need to be fulfilled. And in this solution, you will see in a minute that also this X509 PKI need to be considered, whether this already fulfills these requirements or need to be adapted. So in the very first step in this option, where we want to reuse the X509 PKI as much as possible, the first step is to register the PKI certificate of the X509 PKI itself at the V2X PKI. For that, we have established a trust between these two components. In the next step, as I shortly explained in the previous slide, a new X509 certificate is created, or the key pairs are created within the vehicle, and together with potentially the factory, a new X509 certificate is issued by the X509 PKI and then provided to the vehicle itself and potentially provided to the vehicle operator. And with that, with that certificate, the vehicle can go into the next step directly to the PKI, show this certificate, and of course sign the request with this keys of the certificate, go to the V2X PKI, present the certificate and show the signature, and the V2X PKI then can verify that the request is valid, because the signature can be verified with a certificate which has been registered in step 1. And therefore, the V2X PKI can directly issue the certificates for V2X, which are called authorization certificates. And here the vehicle can request then directly or indirectly via this vehicle operator network the authorization certificates directly from the V2X PKI, and presenting in all these cases the enrollment, the X509 certificate, enrollment certificate. And you can see it's minimized these new processes here on the right-hand side, because the existing infrastructure is used as much as possible. And this solution can be used for all the 3 areas or the markets in Europe, in North America, and with the Chinese standards, because all these standards allow this use of the enrollment certificate. There are some minor differences in the different variants, in the different standards, but in general, this option is supported by all of them, and an OEM that is operating globally can use this option to have the same enrollment and registration process in the different markets, which is very efficient, because all the existing processes between the X509 PKI and the OEM can be used, and there is no need to change them. So the solution is simplified. This architecture is simplified to lowest number of additional processes. But on the other hand, you have to consider that the existing V2X PKI fulfills all the requirements that are given from the standardization, certification, and audit requirements given in the market. In Europe, we have a quite clear situation, because we have the policy available and can do all the checks. And here, it needs to be ensured that the V2X PKI is operated in a secure environment, is fulfilling some operational aspects, is fulfilling some technical and crypto aspects regarding key management in hardware security modules, and so on and so forth. This can be checked, and if this is all fulfilled, there is even no need to adapt the X509 PKI landscape. If there is a minor gap, this can be potentially filled by adapting this slightly by potential updates. But in general, this need to be considered for this option. So it's yeah, very efficient option, but has to be has some checklist to be validated. For the second option, we want to avoid this direct involvement of the X509 PKI into the certification and the audit of the V2X PKI, because in case the X509 PKI is not fulfilling all these requirements and there is no way to adapt the operation to migrate it into another, I would say, yeah, data center or environment that is potentially fulfilling the requirements. If this is not possible, then this option can be used. And in this option, there's another step in between, because first, again, the certificate of the X509 PKI is registered at the V2X PKI to establish common trust between these two components. But then in the next step, the X509 certificate, which is here created in step 2A, in the same way as in the previous option, this certificate is not directly used as an enrollment certificate to get the authorization certificates for V2X, but instead this certificate is used to provide some basic information to the PKI in the registration phase. And this is a so-called canonical key, which can here provided as part of an X509 certificate to the PKI and therefore being registered at the V2X PKI. And then this individual step is completed, and now we can switch to the full standardization, for example, in Europe to ETSI, in North America to IEEE, to follow these standards to get a V2X specific enrollment certificate based on the authentication done with this registered key material provided in step 2C. And then finally, in step 4, the vehicle can directly get its authorization certificates to use them finally on the road to sign messages. So here you can see there are some additional steps required because the X509 certificate is not directly used as an enrollment certificate, but is used as an authenticator to allow the registration of a V2X specific enrollment certificate. So it's a mixture. We are still using the X509 PKI in this case, in this option, to reuse the management operations for the OEM to update the credential management on the vehicle for X509, but it's not directly integrated into the scope of the V2X audit because we have in step 2C a clear separation with a clear interface, and we have no direct integration of the existing PKI landscape. Right. And then if we come to option 3, yeah, this is then without an existing X509 PKI. And here we are using a so-called DCM certificate. It's just a name. It's a device configuration manager certificate. It can be of each type. For example, we could use here also an X509 technical type, but it's not set. We could also use some other technical type to provide a so-called DCM device configuration manager certificate to the PKI, and this is then used as the authenticator to register, similar as in step 2, vehicle cryptographic information. So the key material is generated inside the vehicle in step 2A, it's provided in step 2B via production infrastructure to the vehicle operator, and then finally registered into the V2X PKI into the databases. And then afterwards in step 3, we are again in the full standardization so that the vehicle is requesting the enrollment certificate from the PKI. This request is authenticated with the key material from step 2C. So it's only provided to registered and valid vehicles. And then in step 4, the vehicle can get its authorization certificate to use it on the road to communicate with others. In this option, yeah, we have the clear benefit that we have a full separation from other use cases, so we don't need to take care about audits of other systems. We can provide the full audit and certification of the PKI, and we just need to provide information how these interfaces need to be protected, but it has no impact of existing other infrastructure. But of course, on the other hand, potentially some modifications are required to the processes, how the management of the vehicles is done. Because for repair, for revocation use cases, this might need to be adapted. Okay. With that, I would give back to Omar to continue with the remaining slides.
Thank you, Norbert. That was a lot of great details. Hopefully, the audience has benefited from this one. Yeah. So to move on, so why, this is, the section of the deck where you focus about ETAS solution and what is exactly what we presented here. Sorry, yeah. So to summarize what in abstract level, what Norbert has presented, it's simply we're trying to offer here a solution to the target audience. It comes into a specific PKI security consulting package, part of our professional services, in addition to, of course, our pilot and production PKI SaaS solution, software as a service, with the different options that have been presented to offload the complexity, the global complexity, and that is important here. The context of having European, North American, and China standard different flavors, some of the implementation, right? Some of the use cases. Not quite, completely different, but there are different flavors that we have to accommodate. So that global complexity is offloaded to us to help automotive OEMs save in cost and time. And that comes into three high-level categories here: the bootstrapping, the IT infrastructure, and the support for audit. The bootstrapping is basically, as presented, is a harmonized PKI bootstrapping operations, processes, communication protocols for the European, North American, and China standards, and leveraging the existing infrastructure. We have the ability to describe the general infrastructure and operations that you would need to run and stand a V2X PKI system. And finally, help our leads and customers to basically go through the challenges of the policy audit. When you stand up your own V2X PKI, or if you want to have integrated solution, you have to go through the policy audit here and requirement setup, and this is what we can offer as well to help alleviate that concern. Now, why you would use our solution here? Because we've proven that we can address these challenges through our compelling consulting and PKI SaaS solution that is able to address the diverse and complex PKI requirement to help save on cost and time. Our advantage as a company, as a solution, we have proven ability in scaling embedded and enterprise security solution. And that's what comes handy to our target audience to help integrate the V2X PKI, realize the V2X feature, and introduce safety on our roads and streets. Now, the summary here, to conclude with that, what we have presented today, there are high-level 3 bullet points that I would like to, as a key takeaway, socialize here. V2X communication as a technology is an emerging technology that enables increased safety and reliability of autonomous vehicles. That's a key element here. It's all about safety and about reliability, about the proposition that the automotive OEMs have to put into the vehicle towards their audience and towards their customers, right? OEMs can save in time and cost by integrating ETAS solution and unleashing the potential of V2X security technology. Realizing the integration of V2X PKI infrastructure, maybe ETAS in this case, with an OEM existing infrastructure is possible, period. That is possible. That is something that you could accomplish by working with our team to help address these concerns. Before I say thank you for today's webinar and for the audience who listened to us and so appreciated that time, the valuable time that you put forward, we have a short second survey. Would like your help to answer and help us be on the same page with you. Shouldn't take that long. It's a couple of questions, and your answers are highly appreciated.